Ms. Cohen here. We are about to begin the second week of distance learning, and this is going to be something slightly new about how to graph quadratics. And I just want to tell you right away that if you are stuck or confused, I want you to reach out to me, and I'm happy to help you. I've been making one-on-one videos for people to help them get unstuck from where they're stuck, so please don't hesitate to reach out if this video is confusing and you don't understand. I also just want to say thank you to everybody who did all the work last week. I know it's a big ask to do all this work without a teacher there to help you, and you're doing awesome. So keep up the good work. This lesson is going to be basically straight from this giant packet that I handed you on the last day of school. It was 40 pages, and I said, I'm sending this home just in case we get stuck at home for the rest of the year, and here we are. If you have this packet, awesome. You're going to use it. In fact, you're going to turn to page 1 right now, which looks like this, okay? So if you have this packet, great. If you don't, there is a link right above to this page where you can take notes on the page if you'd like. And if you don't want to take notes on the if you don't want to print it or you aren't able to print it, then I would like for you to just get out a piece of paper and take notes on paper. It's no issue. We're going to try to keep this video pretty quick. Before we get to the notes, I'm hoping that you all had a chance, let me see if I can find this, you all had a chance to do the Desmos warm-up, which was here. This is screen 7 of 8. So let me go back to the beginning, actually. So the first thing that I had you do on this Desmos thing, 3, 2, okay, was take y equals ax squared, and we learned last week that here, let me move this. Last week, everything we did started here at the vertex, okay? And that's because there was no k out here, or this value was 0. It was just y equals ax squared. And what a did was it stretched or flipped the parabola, right? Right side up if it's positive, upside down if it's negative, and the bigger a is, the higher up those points go. So if a is 2, there's our vertex. We go over 1, we go up 2, boom. All right? Now, this week, going back to this Desmos thing, this week we are moving it around. Oh, I didn't mean to do that. Hold on. Let me go back. Boop. Okay. So you started on this Desmos activity going just up and down. So it turns out that this value up here moves the vertex. So if this value is 2, like it is now, then the vertex is up 2 from the origin, right? If that k value is -3, right, then the vertex is down at -3. So if we add a number to the end of our equation, it just moves the whole vertex up or down. And then a does the exact same thing, right? So if a is 3, then our vertex is down here at -2 because this number is -2, and we go over 1 and we still go up 3, right? It's just that, be careful, it's not up here at the 3, it's 3 up from the vertex, okay? So then at the very end, I was asking you to play around a little bit with this. This is vertex form of a quadratic, and we're going to be working with this form all week. And so a lot of this stuff is the same. A, if I mess around with that, it's going to stretch it, right? Okay, so that's no different. K, which is the number out here to the side, moves the vertex up and down, just slides it up and down. Now, if we have parentheses around the x and we have a number in the parentheses with x, that is going to slide it left and right, okay? And that's really all you need to know for today's lesson. So if it's in this form, it's called vertex form, we can see what the vertex is, okay? Right now, h is 2 and k is -2, and so the vertex is located at 2, -2. And then we have a stretch, all right? So let's go to our notes. So again, if you have these notes, fabulous, and if you don't have these notes, then you're just doing this on a piece of paper, and that'll be just fine. All right, So the essential question today, how do I graph a quadratic function that is in vertex form? So this is vertex form. Ugh, this video is choppy, sorry. Okay, so A is the stretch. That's not new. Okay, and so the stretch tells you from the vertex, you go over one, and you go over one left and right, and then you go up or down A, whatever A is. Okay, that's how we use the stretch. K tells us to move the vertex up or down K. All right? And then H tells us to move the vertex left, I should have said left or right H. So when we have an equation in this form, the first thing we're going to do is locate the vertex. And so I want you to write over here how to graph. And again, if you don't have this page, then I'm probably going too fast for you because you have to get all this other stuff down. So feel free to pause the video whenever you need to. So step one is to locate the vertex at H, comma, K. Okay? This will be the x-coordinate of your vertex. This will be the y-coordinate of your vertex. But I don't know if you remember this from like way back. That matters, okay? That means that we have to take the opposite of what this looks like because it's minus h, right? That's not the case here. This is positive k, but this is negative h. And so I just want you to make a note that you have to sort of take the opposite value from what it looks like. And we'll do an example of that in a minute. And then the second thing you do is use the stretch to find more points. So again, I'm going to write it again. We're going to go from the vertex. You're going to go over one in both directions, and then you're going to go up or down A. We go up if it's positive, we go down if it's negative. Y'all, that is it. That is it for this lesson. Now, we haven't done any examples, but it's not complicated. It is new, though, so it's going to feel weird at first, but I promise you will get it. I'm going to come back to these special cases in a minute. I want to actually do examples 1 and 2. So in example 1, we are learning how to graph. If you don't have this page with you, then go ahead and pause the video, and I want you to copy this equation down and go ahead and set up a really simple graph. Don't overdo it like we did in the last video. Make an x and a y axis, go 4, 4, 4. Okay, don't make all the grid lines. That takes forever and it's not necessary. Okay, so first thing we have to do is identify the vertex. And the vertex is located at HK. H is the number in parentheses with x. K is the number off to the side. So the number in parentheses with x is this -3, but we have to take the opposite, right? Because basically we have to do negative of whatever h is. So we have to do negative of -3. So the vertex here, in fact, I'm going to write it above. Okay, the vertex is at +3. And then this number, we just plop straight down, -8. So the vertex is at +3, -8. So again, you take the opposite of the number in parentheses with x, but this number plops down, whatever it is, positive or negative, okay? The stretch is going to be the number in front of x, which in this case is 2. Domain and range we're going to skip, so you can just cross that out. So that's your first step, okay? Vertex, vertical stretch, and now we're going to graph it. So 3, -8, +3 on the x-axis, -8 on the y-axis. Make your vertex, okay? And now we use our stretch. Our stretch is +2, and so you're going to go over 1 in both directions, and then we're going to go up 2. And then you make a U. Whoops, I missed my point. But you get the idea. Excuse me. Okay. Awesome. The very last thing we're going to do here, we practiced this way back when, before school was canceled forever. And that's axis of symmetry. So axis of symmetry is always going to be a vertical line that cuts right through your vertex like this. Okay, and it's the line that cuts your parabola in half. And we always write it in the form of x equals whatever number this hits on the x-axis. So in this case, it would be x equals 3. Okay, let's try example 2. In example 2, we're going to do the exact same thing. This time, though, we're given the graph, and we have to write the equation. And so the first thing we're going to do is locate the vertex, and the vertex is right there. Okay, so that vertex is located at an x value of 1 and a y value of 3, 1, 3. Now we have to somehow identify the stretch, and this is a little tricky on this problem, but we can do it. We're going to go over 1 in either direction. It does not matter. Okay, we're going to go over 1, and then we're going to go down until we hit our parabola. And the reason this is tricky is because we went down not even a whole unit, right? We went down half a unit. And because we went down, a is negative, and so a in this case is going to be negative 1/2. Okay? All right, now let's write the equation. Y equals, and I'm going to sneak back up here to look at vertex form. The first thing I have to put is a. A in this case is negative 1/2. Then I need parentheses. Then I need an x. Then I take the opposite of h. That's really important. H is the x coordinate of my vertex. And so in this case, I have to take the opposite of 1. And so I'm going to put a -1 in here. And then the thing that everybody always forgets is that squared. We have to put the squared on. And then the next thing I do is plus k, right? If k is positive, we would put plus k. If k was negative, we would put minus k. In this case, it's 3, right? The second value of my vertex. And so I'm going to put plus 3. That's it. So my vertex is located at 1, 3. That checks out. Okay, the opposite of this, so 1, 3. And the stretch is negative 1/2 because I'm going over 1 and down 1/2. Domain and range we're going to skip. Axis of symmetry is the vertical line that cuts right through. And that's located at x equals 1. And just kind of a little hint, it's always going to be the x coordinate of your vertex. Okay, 2 more and then we're done. Also, feel free to pause and rewind. If you're confused, watch it again, okay? All right, example 2. So example 2 is another graph, and I have to write the equation. If you want to pause and try this on your own, I think that would be awesome, but this one's a little different, so it's okay if you want to just stay tuned. There's my vertex. It's the middle point on the parabola. So the vertex is located at an x value of 0 and a y value of -6. So I'm noticing that the y-axis here is going by 2's. The stretch, I'm going to have to be pretty careful here. I'm going to go over 1 and I'm going to go up until I hit my graph. And it looks like it's 1.5, but since we're counting by 2's, I have to make sure I take that into account. So it kind of hits like here, right? And it says -4, so that would be -3. So here I'm actually going up 2 and then another 1. So I'm going up 3. Because I'm counting by 2's. I hope that makes sense. Okay, so the vertical stretch is 3 here, so you have to pay attention to the scale. I might even write myself a note. Scale. All right. If you have the vertex and the stretch, you can write the equation. So y equals, in fact, I definitely want you to pause the video right now and write the equation, okay? Okay, so y equals a, the vertical stretch. The vertical stretch is 3. Then you need parentheses. Then you need an x. Then we do the opposite. The opposite of 0 is 0. Like, what does that even mean, right? So I'm going to write -0. Don't forget your squared. And then since this is a -6, I'm going to write -6. Domain and range, don't worry about. Now, you're welcome to leave your answer like this, okay? But I hope that you recognize back at the beginning of the Desmos activity, this parabola wasn't moved left or right at all, just down. And that's because this minus 0 is unnecessary. Subtracting 0 doesn't do anything. And so the better way to write this equation, since I don't need the 0, I don't really even need the parentheses. It's just 3x squared take away 6, right? A vertical stretch of 3, and the parabola was moved down 6, but since it was not moved left or right, we don't need that part of the equation, okay? So I want you to come back up here to this special cases thing. It looks like this. If the parentheses are not present, all we do is move vertex up or down, but not left or right. Okay. Last problem. Example 4. So in example 4, we're supposed to graph this equation. So the first thing I'm going to do, this negative here is going to kind of trip me up unless I put a 1 there. So I'm going to stick that Ninja 1 back. And now first thing I have to do is locate the vertex. So the vertex is located at HK. H is in the parentheses with x, but it's the opposite of what it looks like. Since this is a negative 3, my vertex will be located at positive 3. Now the K is missing, right? There's nothing here. What that means is that my parabola was not moved up or down. This is just not there. Now if I wanted to write, I'm going to write this over here to the side, negative 1 and then x minus 3 squared plus 0, these two equations are the same. And so that gives you a hint that the y value of the vertex will be 0. So if nothing's over here, go ahead and put a 0 there. The vertical stretch is what's in front of the parentheses, which is negative 1. So let's go ahead and graph it. 3, 0, x coordinate of 3, y coordinate of 0, so we're not going up or down. The stretch is negative 1. So from the vertex, we go over 1 in both directions, and we go down 1. And there's my parabola. Domain and range we're skipping for now. And the axis of symmetry, x equals 3. So take a minute, either on your own paper or on this worksheet, and I'd like you to do your best to write a summary of this. And then, here, let me find myself. Where is it? Here we go. There I am. Okay, so I just want to go over what you're going to be doing next. So write a quick summary of these notes if you're able to do that. And if it's too hard, fine, skip it. And then there are going to be 2 quick multiple choice questions for you to answer. And just like last week, if you get them wrong, I'll tell you you're wrong, and then you'll have a chance to go back and fix it. And then there's a con activity for you to do that goes with this lesson. It's optional. I really recommend it, though, if you have time this week to do it, because this is new and kind of trickier than what we did last week, and some extra practice will be really good for you. So once you're done with the con, it's optional, but hopefully you do it. Then there's a homework assignment to do on, it's like a little Google quiz form. So that's it for the week. Please, please, please reach out and let me know if you have any questions, and you're going to be fine. Good luck.